The other part of remainder theorem that we've done where we had to find just one k value, but now we're going to do where we actually are missing two values. So when p of x equals 3x cubed plus mx squared plus nx minus 7 is divided by x minus 2, the remainder is negative 3. So how can we write this in a form that would be helpful? Divided by x minus 2, the remainder is negative 3. P of what? P of, not negative 2, P of 2, because we use the x value, not the factor, right? And what does it equal? Negative 3. Because our remainder theorem states that if we fill this in for all the x's, we'll get it equal to the remainder. Leave that little box there for just sitting for a little second. It is also known that p of negative 1 equals negative 18. What the heck does that mean? What does that mean? P of negative 1 equals negative 18. I'm filling what in for x? Yeah, and then I get an answer of. So there's actually a point at negative 1 and negative 18 on this graph, correct? And I have a coordinate of 2 and negative 3 on this graph. We agree? I also have x plus 1, but is that a factor? No, because the remainder is negative 18, so it's not actually an x-intercept, right? It's a point 1 and negative 18, negative 1 and negative 18. And this one's a point of 2 and negative 3, so it's not an x-intercept. So x minus 2 is also not a factor, right? Because you'd have to have the remainder of 0 for it to be an x-intercept. So we know we can fill these in, so we're going to fill them each in separately. We're missing two variables. If we're missing two variables, we need two things like we have. We can't just get away with one now. So we missed k before. We could have one of these, fill it in, solve for k. Now we're missing two. We need two of these. So we fill in for x, set equal to the remainder. So we're going to get 3 times 2 cubed plus m times 2 squared plus n times 2 minus 7 equals negative 3. 2 cubed is 8 times 3 is 24, plus 2 squared times m is 4m, plus 2n minus 7 equals negative 3. And then what we want to do is we want to get mn equals number. So we're getting an actual linear statement like we did in grade 10. Yeah. Nope, because the squared's only 2. Yep. 24 minus 7 is what? 4m plus 2n plus what? What's 24 minus? And then I'm going to move the 17 over. So 4m plus 2n equals, subtract 17 from both sides. What do I get? Negative 20. So that's my equation 1. Then I'm going to do the exact same with equation 2. So I'm going to get 3 times negative 1 cubed plus m times negative 1 squared plus n times negative 1 minus 7 equals negative 18. Negative 1 cubed is negative 1 times 3 is negative 3. Negative 1 squared is 1 times m is m. N times negative 1 is negative n minus 7 equals negative 18. Negative 3 minus 7 is what? Minus 10. Add 10 to both sides. And I get m minus n equals negative 18, equation 2. Now we bring back grade 10. elimination or substitution. So I always choose elimination just because I think it's easier. So what do? We stack them on top of each other. So we have our two equations. We have 4m plus 2n minus 20 equals negative 20. And then we have m minus n equals negative 8. So now what I always try and do is make either the m's or n's the same but opposite signs. Why would I want them to be opposite signs? Remember? So they can cancel by addition, not subtraction. If they're the same sign, I have to do subtraction, then I have to be like 3 minus a minus 3. Okay, that's plus, and then your brain hurts, right? So it's just better if you can add them, which means make them the same but opposite signs. So I'm going to make the n's be the same just because I feel like they're easier. Could you make the m's be the same? Multiply the bottom by negative 4? Absolutely, it'd be just fine. But I'm going to multiply the bottom by 2. And what you have to remember to do is multiply the entire bottom equation by 2, including the negative 8, which some people forgot, grade 10 all the time. So we get 4m plus 2n equals negative 20. And then we get 2m minus 2n equals negative 16. Add. When we add them, we get 6m. Then you write the n's cancel, equals negative 36. Divide by 6. And m equals negative 6. And then people stop. But what haven't I found? N. So now you can go back to either equation 1 or equation 2, put in m and solve for n. I'm going to pick equation 2 because it looks easier. Could you pick equation 1? Absolutely, it doesn't matter. So I'm going to get m minus n equals negative 8. M is negative 6, so I'm going to get negative 6 minus n equals negative 8. Add 6. Negative n equals negative 2. And then what do I have to do? Either multiply by negative 1 or divide by negative 1. So I get n equals 2. So then I would say m is equal to negative 6 and n is equal to 2. Could we check these? Yes. 2 and negative 3 is a coordinate on this graph, right? Negative 1 and 18 is a coordinate, negative 18, sorry, is a coordinate on that equation. We agree? So can I not fill m and n into that equation and just type in my calculator and see if those actual points exist? I can walk away from this question knowing I'm completely correct, and I'm back checking my work, right? You should, for most of the part, be able to work your way back and see, hey, am I right? Okay? Just make sure you check correctly, because some people check wrong and then they think they did it wrong, but they actually just checked wrong, and it's a bit of a debacle. So, where's my calculator? Oh. This. So what is it? What's the equation with the m's and the n's? Help me. 3x cubed, I think. Okay, and my can't be squared. Yep. So what's the m now? Ooh, get down there. Plus negative 6x squared. Which ones are we looking for? What, negative 1. And what was the other one? Oh, we're just so smart. Sure, why not? Oh, isn't it pretty? Yeah, it's a cubic function. Isn't it pretty? Looks like sideways S. Like Superman. possible. It's real. Okay. So we have the factor theorem, which we basically talked about already. The factor theorem is very similar to the remainder theorem, except the remainder is 0. It has to be 0 in order for the divisor to be a factor. So what does that mean? If when you fill it in, you get PB of 0, what kind of coordinate is that? P of B equals 0. It would be an x-intercept at, what would the coordinate be? B, comma, 0. This is my x, this is my y, right? I'd have a coordinate at B0, correct? Which means I'd have a factor at x, what B? I have a factor at, if my have this one's x equals B, so what would my factor be? X. Work your way back, guys. X equals B. We're just working back. How would I move this back over with the x? Subtract it. Yep. X minus B equals 0. We agree? So if x equals B, the factor is negative x minus B. So this is a factor. You guys have always went from the factor to the root, correct? You can go backwards, root to factor. So verify that x plus 2 is a factor. If you see is a factor, you should instantly be underlining it and writing remainder 0. So ultimately, we're looking for a remainder of 0. So we're going to use the remainder theorem. Bless you. We're going to check with our calculator, and then we're going to do it by synthetic division. 3 different ways we could do this exact same question. So if this is my factor, x plus 2, what am I going to fill into my remainder theorem? P of negative 2, because we'd solve it, right? X plus 2 equals 0. X equals negative 2. It's only a factor if my remainder is 0, because then it would be actually an x-intercept, correct? Okay, because we're just getting coordinates here. So we fill it in and we get negative 2 cubed plus 5 times negative 2 squared plus 2 times negative 2 minus 8. Negative 2 cubed is what? Negative 8 plus 5 times negative 2 squared, so 4 times 5, which is 20. 2 times negative 2, which is negative 4 minus 8. So now we have negative 8, and negative 4, which is negative 20, plus 20, which is 0. So we know we have an x-intercept at negative 2, 0. We agree? So I'm not going to use this example for these. I'm going to use the above example. So this is the remainder theorem part. Now we're going to use our calculator to check it. So if we plug this into our calculator, if this is a factor, there should be an x-intercept at negative 2. We agree? You're going to have to give me the equation. What's the equation? X cubed. Then we go second table, and we're looking for negative 2 and hoping there's a, and there is. So that means there's an x-intercept at negative 2, 0, which means x plus 2 is a factor. Oh, light bulb moment. Angels coming down. All these great things. Wouldn't it be cool when you like actually get something that a little light bulb like pops up over your head and it like lights up, and I'd be like, oh, she's got it. Oh yeah, he's got it. Oh yeah, this is good. Oh, that's a dim bulb right there. They're gonna get it. They're gonna get. Oh, it's good. Yeah, yeah. So now that we actually do have written response, if they want you to work them down, this would be a good place to put a written response for sure. So these ones you could pull right completely off of your calculator, because these ones are actually straight up questions, right? But some x-intercepts could be decimals, and they're not going to appear in your table of values. But you could find them by second trace values. So yes, there's that way. So that would be a better written response question for sure. But the case solving ones or whatever, those would be a good numeric response question because they're not giving you the answers. It wouldn't be the best multiple choice because you could technically plug them back in as your k-values and see if it works. So yes, now there's written response. I'd say polynomials would be probably a really good written response type question. But we'll see. We will see. 5, 2, and 3. 2 parts, one worth 2, one worth 3. Okay, now we're going to do synthetic division. At first, seems redonkulously overwhelming, but it's not. You just repeat the same things over and over and over. Okay? All right. So we're going to draw ourselves an L. Watch the L. Don't draw the L until I explain the L. You're going to draw an L. The first L that I ever drew in my life, no one explained this to me. I had to use whiteout. That you had to use from a bottle. That you had to wait 7 years to dry. So it caused you super ridiculous heart palpitations. So I'm not going to have you there. I should have been using a pencil. Yeah, okay, but I wasn't. I was using a pen. You're going to need a row of numbers up here in this area here. You're going to need a row of numbers. Don't draw a line. That's ridiculous. It's going to go away. I'm going to erase it. And you're going to need a row of numbers here. So keep in mind this L needs to be a slight rectangular shape that has a longer width than you would imagine. Because you're going to have a row of numbers here and a row of numbers here. Yeah. Sideways L with quite a nice bottom. Okay? Sure. Yes, a reflection in the y-axis and then rotated counterclockwise. 90? Boom. I like this. We're bringing some grade 9 rotation back in. Transformations? We do rotations in grade 9. True. All right. So synthetic division, what we need to remember is, can we count down? So that means we need to have an x for every single exponent downwards. So in this case, we have an x cubed, an x squared, an x to the 1, and a coefficient. Or a constant, sorry. We have a constant. So cubed, squared, 1, constant. We're good. However, if we were missing the squared, let's say it was x cubed plus 2x minus 8, we'd have to put a 0 in for the squared placeholder. You always have to check if you can count down. If you can't count down, say it was like 3, 1, 0. In for the degree 2, I'd have to put a 0. Okay? You have to have a placeholder. Make sense? So all we're going to do is write the coefficients. So what's in front of the x cubed? A 1. What's in front of the x squared? A 5. What's in front of the x? A 2. What's in front of the negative? Because this would technically be x to the 0, right? Because x to the 0 is just 1. Anything to the exponent 1, 0 is 1, sorry. And then what we put up here in this little spot, it's recording. You now have to stop. Okay, so we have x plus 2. Do you agree? So that's our factor. In our remainder theorem, we used our root, correct? Our root, our 0 or x-intercept. The great thing about it is we're going to use the same thing for synthetic division. So you don't have to think, hey, do I use one for what? Always use the root, okay? So we have x plus 2. So I put negative 2 in for all my x's for remainder theorem. I'm going to do the same thing here. I'm going to go x equals negative 2. So in front of my synthetic division, I always have my root. In my remainder theorem, I always have my root. If you use subtraction instead of addition, you would use your factor. I just use my root in both. Okay. So following along, this is where I'm going to kind of slightly lose you, but all we're going to do is we're going to carry the number down, and then we're going to multiply, add, multiply, add, multiply, add, until we're done. Carry the number down, multiply, add, multiply, add, multiply, add, multiply, add, till we're done. That's it. Looks super overwhelming, but literally we're just multiplying and adding. And within 3 questions, you're like, oh, this is stupid easy, because it is. Okay. Arrow down. I'm carrying the 1 down here. Boom. Literally. That's my first step. Then I'm going to multiply these two. What do I get? Negative 2 times 1. Negative 2. So I'm going to bring it up. And now I've multiplied, so I'm going to add. 5 plus negative 2 is 3. And then because I've now added, I'm going to multiply. Negative 2 times 3? Negative 6. And because I now multiplied, I'm going to add. 2 plus negative 6 is? And now I just added, so I'm going to negative 2 plus times negative 4 is 8. And then I'm going to add. And now I'm happy because guess what? I boxed this baby because it's my remainder. So I can use synthetic division to find my remainder. Absolutely. Now, what's up? Positive 2 plus negative 6 is negative 4. Waiting for that light bulb. Super dim. There it is. Yes, the light bulb. Good. Okay. So, the good thing about synthetic division, remainder theorem literally just gives you a remainder, or we can solve for a missing variable. We agree? Synthetic division is better if it asks you for all the x-intercepts or the factors, because remainder theorem doesn't give you that at all, does it? It gives you one, possibly. That's it. So what we do is we have x equals negative 2 here. That's one of our x-intercepts. We know that. Now we have this lovely number left down here. If we take out one x from an x cubed, our next thing that's left over is an x squared. So this is an x cubed, correct? But I've taken one factor out already. It's sitting out in front. So then this here is going to be an x squared. So what am I left with? I'm left with x squared plus, let me just work my way down, 3x minus 4. So I know I have one factor. If I wanted this in factored form, I'd have x plus 2 already. If I wanted in x-intercepts, this is factors. This is roots, zeros, x-intercepts. We agree? How could I get the other ones? What did we do last year when we saw this? Factor or? Yeah, or? If you can't factor it, very top left of your formula sheet. Quadratic formula. So if you couldn't factor it, you would write it whole as the trinomial right beside here, because you can't factor it. But if I asked for roots, you'd have to put in the quadratic formula. So if I ask you to factor, it's happy if you can't factor. You just write it again. But if I ask you for roots, you'd have to quadratic formula it. Okay? So we can factor it. It's going to be what times what equals negative 4, what plus what equals 3. And it's nice because it has a 1 in front. You can go right to bracket. What's it going to be? Positive 4 and negative 1. So I get x plus 4 and x minus 1. So I have all my factors now. X plus 2, x plus 4, x minus 1. I can have at max 3 factors because it's x cubed, right? When you did x squared, how many factors did you possibly get? 2. How many roots could you possibly get max? 2. So if it's cubed, you can get at max 3 factors or 3 roots. So what are my roots? These are my factors. Negative 2, negative 4, and 1. Could I just go to my calculator and type this equation in and look for the x-intercepts off my table of values? In this particular case, yes, because all of them are whole number, well, integers, not whole numbers. Whole numbers start at 0. Okay? So depending on what I'm asking you, synthetic division can give it all. If I ask for the remainder, it can give you the remainder. However, if I ask you for just the remainder, is remainder theorem not just faster sometimes? Yes. Some people really like synthetic division and will only use remainder if you need to find k or m and n, right? So remainder theorem is forced to be used if you're looking for k or m and n. But if I just asking for the remainder, you could just use synthetic division. Synthetic division also gives you all the factors of the equation, and it also gives you all the x-intercepts of the equation, right? So synthetic division gives you so many things. That makes sense? I know. So he just uses the factor instead of the root, and then subtracts. Same thing. It's not. Okay. Okay. So we want to factor this one. The other one, they gave us what we were dividing by, right? This one, they don't. They just tell us to factor. So what we want to identify the possible zeros or x-intercepts. The possible zeros come from the back number, the constant, all the factors of it. So my possible zeros are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. So how would I know which one is actually a zero? You could use remainder theorem or synthetic division, plug each one of them in separately till you get a remainder of 0. Exactly. Or binoculars. Yes. So you get a remainder of 0. Okay? But what we can do, so if they asked you to actually show them what a possible 0 could be on the diploma, you would actually have to try them out and prove that the remainder is 0. Okay? By the remainder theorem or synthetic division. How else could we determine with our calculators what number we could use in our synthetic division to get a 0? Graph it or put it into your, go to your table of values and look for when, what? Y is 0, right? Because in the previous instance, y was 0 because when the remainder is 0, that's just the y value to the x, correct? It's just a coordinate, is it not? So we just need to look for an x-intercept on our calculator. So let's type it into our calculator. Where is my calculator? So what do we have? Sorry? So there's a whole bunch of them. It actually gives us all 3 of them. So you can see why this is not this question would not be a multiple choice or a numeric, right? Because you have to show no work if you use your calculator. No. So we have -3, -1, or 2. We can pick any of them. I'm going to pick 2 because it's the positive one. So that means x equals 2. We agree? Okay. This one actually says to factor. So do we want the x-intercept? If it says factor? No, we want the factors, the step before, correct? So if I'm using x equals 2 in my synthetic division, I also have a factor of what? X minus 2. And I'm going to go right to the end, and I'm going to put x minus 2 as one of my factors. Why? Because that's the one everyone forgets to write, because it's up here. So I go right at the end, and I put x minus 2 so that I have it right away. Because everyone remembers to rewrite the factors that are at the bottom of the synthetic division. They just forget the top one. See how that's possible to do? So the first thing we have to do synthetic division is we have to make sure we can what? Count down. Count down our exponents. Because if we can't, we have to put a placeholder. Do you think per chance we might have one that's missing on the diploma? So that could be an error where you put the 0 and don't forget to remember to put the 0. Yeah. So we have to make sure we can count down. So we have exponent of 3, 2, 1, constant. So we're good. So we can just write the coefficients. So we have 1 in front of the x cubed, 2 in front of the x squared, minus 5 in front of the x, minus 6 as my constant. Now what do I do? Bring the 1 down. So I have 1 times 2 is 2. I wouldn't use arrows normally. I'm just doing them still for this practice. Then what do I do? 2 plus 2 is 4. Then what do I do? Multiply. 2 times 4 is 8. Bring it up here. Then I add. Negative 5 plus 8 is 3. Then I multiply. 3 times 2 is 6. Then I'm happy because I actually pulled the x-intercept off the table of values and not the y-intercept, which some people accidentally do. Because we don't want when x equals 0. We want when y equals 0, and people will pull the x-intercept off and use, or the y-intercept off and use that. And then they're like, it doesn't work. I'm like, yes, because it's, it's not what you want. Okay. So have we factored it completely now? No, we need to write out the quadratic. Our quadratic is 1x what? Squared, because it's always 1 less. So this is an x cubed, so it's going to be 1x squared plus 4x plus 3. And then I say, what times what equals 3? What plus what equals 4? What's it going to be? 3 and 1. 3 and 1. I'm going to get x plus 3 and x plus 1. I don't have to do decomp because there's a 1 in front. So those are my factors. So people will write that and then they'll box it. Do you see how that's an error? Because we still need the x minus 2. So my actual answers are x minus 2, x plus 3, x plus 1. And then they're not sure what I ask, so they also give me the roots. Is more better? No, more means you actually don't know what I'm asking, so you're going to give every possible answer you could possibly come up with and hope that I mark it right, which is not good. So if I ask for factors, I need the factors. If I said solve, what does solve always mean? It doesn't matter what unit we're in. What does solve mean? Roots. Tell me what the heck the variable equals, whether it's an x or an m or a w, whatever. You need to tell me what the x equals. So if it said solve, I would go one more step and I'd say x equals 2, negative 3, and negative 1. Correct? But if I put that as an answer right now and I boxed it, would that be a good idea? No, because you're not answering what I asked. I asked you to factor. Yeah. When I ask you to solve, which will be in the next lesson. So if in the end you went to go factor something and it wouldn't factor, then you couldn't factor it, and you would leave it as like the first factor and then the trinomial. You couldn't go further. Okay? So your job this weekend is to practice transformations, and we will deal with this